Take a guess. Saltwater or freshwater? All right, so that is what everyone thinks. Everyone thinks that if you freeze salt water, you just get fresh water and the salt gets left behind, because that's kind of what happens when water from the ocean evaporates. The salt doesn't evaporate, but that's just not what happens. When you freeze salt water, it really does freeze as salt water. So if you melt sea ice, which is the frozen sea, you do get salt water, which is totally not what everyone thinks. Which one was that? So I can't even find the one. Here we go. So number 11, if you tasted melted sea ice, it would be salt water. Number 12, Chris, where do icebergs come from?
Icebergs come from glaciers.
Right. Okay, so glaciers. Oh, that's the next question. Bethany, I won't say it. I always give away the answer. Where do glaciers come from?
Hard packed snow that just gets packed so tightly that it practically becomes ice.
Okay, so where do they usually form?
Usually in polar areas like Alaska, places that are really cold, and then you have a lot of snowfall, so much that it gets so deep that it's so compressed that sometimes then they'll break off the side of like a mountain after shifting so far to the sea.
Right. So if you think about a glacier, right, if you're on top of a mountain where its altitude is so high that you don't get melting, and then snow falls and more snow falls and more snow falls, but it never melts, then the weight, like you said, just crushes and compacts that snow into ice. And then as more falls and more falls, it pushes itself down the mountain. And so glaciers travel, and each glacier kind of has a characteristic rate, and then people get all worried if the rate of each glacier changes, speeds up or slows down. But anyhow, the glacier will move down the mountain, and if it moves down a mountain and ends up at the sea, it will eventually like push its way out so it's kind of overhanging the sea. And if
like
it, yeah, like a cliff, but then the weight of itself will eventually cause it to fall. And there's some beautiful videos of glacier calving. It looks like, the word calf, like a little baby cow. But when a glacier breaks, it's called calving, and it just falls into the ocean and makes a gigantic splash. And when people shoot a video of it, it's really fun to watch. My kids are mesmerized every time we watch them. So definitely take advantage of Mrs. Hastings' site and watch some of those videos when they break off. So if glaciers are, let's see, nope, that's not what I'm going to ask. Okay, if glaciers are caused from snowfall, is snow freshwater or saltwater? Freshwater. So are the icebergs that break off of glaciers made of freshwater or saltwater? Freshwater. So they just float in the ocean, but they didn't come from freezing sea ice. They came from the top of a mountain where the snow, which is freshwater, fell. So they are made of freshwater. Let's see, where am I? Jenna. The captain of a ship sees an iceberg and steers clear of it. Why is the captain still worried about a collision?
Because most of the iceberg is underwater.
Right. Most of the iceberg is underwater, so it's not visible. So even if you stay away from the part you can see, much, much more of the iceberg is underwater than the part you can see. So you have to, yes, must stay way clear, way clear. I skipped 14. I may actually,
I can kind of answer it though when you're talking.
okay, I still have the old version of the study guide, so that was 14 on my paper. What was your 14?
That was a question about
Process with a portion of glacier breaks off possibly water.
Oh, well, I don't have that question, but yep. And I don't have a note about that either. I need to make a new copy. Yep, calving is the breaking off of an iceberg. The glacier breaks and an iceberg falls. Well, the broken piece of the glacier is now an iceberg as it's in the ocean. Well, Lily, I have number 15, which may or may not be the same as yours. What I have is, suppose you study two areas of land close to one another. In the first, there are many trees, and in, we haven't talked about this at all. In the second, there are almost no trees at all. So let's kind of look at that situation on the board. Maybe I'll film the board really well, so Jessie will have it when she gets her copy. Definitions that are on the test right there on the film. So then we'll look at what we might see. I need a book. Rock, battery, something. Well, I'll just write on the bottom. So, tissue. When we talk about the water table, we'll draw our two situations here on the board. And so, you learned last week that when rain falls, precipitation falls onto the ground, it becomes what? Not quite yet. Soil moisture. So when precipitation falls, it becomes soil moisture. Then there's a process by which it can move into the groundwater. And what is that called?
Percolation.
Percolation, just like making coffee. Percolation is as the soil moisture moves down, it can become groundwater. Now, the place between where you have soil moisture and where you have groundwater is determined and changing. Soil moisture is present where the soil is not completely saturated with as much water as it can hold. And then you move into the groundwater where the soil or river or whatever is down there is completely saturated. But there comes a place where the soil is not saturated above. Well, I might want to move the groundwater down a little bit. And the soil is saturated below that line. So percolation gets you all the way into the groundwater. But there's a water table right here which can change. I'll make a dotted line. And that water table is the division between where the soil is not saturated with as much water as it can hold, and it is saturated below that line with as much water as it can hold. So if you have two areas that are very close to each other, and one has no trees, and one has lots of trees, weird trees, so you would expect what to be similar. These areas get about the same amount of rain. They have about the same type of soil, right? So if the rain falls equally on the two places, and everything else is pretty similar, Lily, what would you expect to find about the water table?
The water table will be deeper with the one with the trees.
And why?
Because the water is being sucked up by some of the trees, too. It's taking up some of the moisture.
Right. So soil moisture is removed by trees because they need the water, right? Soil moisture is removed by trees. So the water table is further from the surface. It's deeper. I can't write the word deeper. Okay. The water table is deeper where you have trees present because they are using some of the soil moisture. There's not as much to go down into the deeper part. So trees deplete soil moisture. Is that the question that is actually on your paper? Mm-hmm. Okay, good. All right, Anna, is this the question you have? If no energy is added to the air, what happens to the temperature when the air expands?
The air will get cooler because there's no energy.
Right, no energy change, so no energy added to the system, so the air has to cool when it expands. That's adiabatic cooling, perfect. And Elise, will fog be thicker in a dusty area or an area that's free of pollution? Yep. If there's more pollution, there's going to be more fog. And Ava, what kind of cooling is responsible for cloud formation? Adiabatic cooling. And Max, what kind of water pollution is the hardest to track back to its source? Different question?
20, I have 20.
Oh, read your question, whatever you
My
have.
question is, a bright student notes that with a few modifications, a refrigerator can become a hot box, keeping things warm instead of cold. Explain. Yes, if the warm gases and liquids never expanded, they would stay warm.
True. Or what could you do to all the pipes?
Oh, they could all be warm.
What? Okay, Duchesne?
You could reverse, like the cold pipes could be on the outside and the hot pipes could be on the inside.
Right, you could just put the pipes that are outside the fridge inside and the pipes that are inside outside, and then you would essentially be heating it up. That's cheating. But that would be a dumb thing to do because it would be really inefficient to use energy to heat up, something with refrigeration when you could just heat up something with...
If you were in the Arctic.
True. I mean, if you had a refrigerator and you were freezing, you could make it into a hot box if you just reversed the pipes and put the outside ones in and the inside ones
Or
out.
just make the cold air go outside and let the pipes keep the warmer coming inside.
You could put a insulated box around the back end of the refrigerator and have both ways, I suppose. I don't have that question on my paper, so thanks. Everyone works together and gets it. Let's see. What is the next question?
What kind of water pollution is the hardest to track back to its
Okay,
sources?
that's the one I have. So Ryan, can you handle that one for me? Thanks.
Groundwater.
Yes, groundwater pollution is definitely the hardest one to track, and why?
If it's underground.
Okay, so how do you know where pollution came from? Like if I drill down and test the groundwater, could I be sure that the pollution came from right above the place where I collected the groundwater?
No.
No, why? What kind of residence time does groundwater have? Longer or shorter than surface lakes?
Longer.
Okay, so groundwater has a super long residence time. So you don't know how long groundwater has been there, if it's flowed from miles and miles away, or if it really did come from right above. And I'll send out a video that really illustrates this with this really cool water table that someone built. Like, not a water table as in Lily's question on the board, but a water table as in a table where water can flow around, and you can really see groundwater pollution being tricky. Bethany?
In my grandparents' neighborhood, someone had taken up a bet to create a whole entire golf course with just like used materials like trash, and then basically he just made this huge dump and then just put turf all over it, and basically it polluted the groundwater, and so they had to buy bottled water for like almost 2 years before they cleared it all up.
Oh my, that is terrible.
And just because some rich guy took a bet.
Wow.
Which really was pretty hard for them because they had to keep buying more expensive water, and so they wasted a lot of money that year.
Yeah, and it's lucky that they even found the source of the pollution because it could have been miles away.
Well, it's really just using water that they're going to drink.
Right.
That's
So possible when shower
still,
water.
yeah.
Yeah, when we were, in China, when we went there, the water that comes out of any tap, from the shower, the sink, anything is potentially not safe to drink. So I'm like, girls, you have to hum in the shower. Don't sing. Don't open your mouth. Don't take a drink because that water is not safe. So I'm like, keep your mouth closed, because Elizabeth especially was little then, and I was just afraid she would let it in her mouth. And Patrick, sure, go ahead. You should definitely not stare at the sun unless you have a special filter.
In China, because
Yes, you can stare right at the sun in China because I mean,
Pollution
as
is so bad.
who told us? Ava just told us that pollution causes more fog and smog, and it literally makes a nice thick filter, so we could quite easily stare at the sun like it looked like the moon. So, what we're gonna do right now, it looked like the moon in the sky during the day, but it was the sun. So here we have a lovely. Oh, I don't even remember. I was so tired the whole trip. It was fun, though. I loved it there. But we have a bottle of dirty, nasty water here. And we're going to talk about how our water treatment plants work to clean up our water. Now, you guys learned that, I know, right? You guys learned that things like hard water are not the fault of water treatment plants because hard water gets hard from what? Joshua?
Particles from rocks where the water travels.
Right, so wherever the water came from, it collected ions that dissolved in it, and those cause hardness. And the water treatment plant doesn't take them out, but it doesn't put them there or somehow cause hard water. So when we look at our dirty water here, we're going to talk about the steps. Now, if you grab your lab sheet that says water filtration, we're not going to do exactly this step by step, but we're going to at least follow kind of the steps, because I think this was left out of the book and probably shouldn't have been. Oops. I'm going to pass out scissors, so while I'm talking, you guys, as long as your water bottle, if it looks like this, pair up with the person next to you, and form some groups. What you want to do is leave the neck of your bottle intact, and you want to take off as little of this part as possible. So you just want to use your scissors as safely as you can, not to stab. Don't do this. Stabbing through your own hand is bad. So cut off the bottom part of your water bottle.
You want us to leave the master?
You want to leave the part where the lid goes intact. We're going to use that part. That big opening might be helpful. If you need, let's open a window and somebody can collect up bottles and dump them out the window if there's a little bit of water in them.
What about the mat inside?
Yeah, just once you dump out the water, you can pour the mats into your hand. Together and make it yeah, if you don't want to use your bottle, just partner up with somebody. Okay. So.
Oh no, where's the mask go? Good job. Did you go outside? It's fine. I take your mat out.
So these are dirty dishes from Plymouth, but they're clean. So I have 6 of these, and I have one little other thing. And so we really only need 7 lab groups, so you'll have to kind of share. Well, I can get 8, because you guys can.
How much of it do you want to take off?
You want to take off just a little bit at the bottom, and when you're done with the scissors, pass them along. This is nasty base, so don't. Alright. Not interesting. So, if you look at your sheet on the back, it says that the first step that a water treatment facility will do to clear up the water is called aeration. And that just means shaking, agitating, blowing air through, like using giant straws. Like if I took a straw and blew bubbles in the water, which I'm not going to, that would aerate the water. And what that serves to do is get any nasty dissolved gases out, right? If you took your soda and you blew bubbles in it and shook it all up, the carbon dioxide that's dissolved in your soda would become undissolved, right? It would come out into the air. Your soda would go flat. Anything you could do to make your soda go flat would also serve to get rid of dissolved gases that you don't want in your water. So now I've got dirty water. I've shaken it up. Hopefully the dissolved nasty gases will come out of it now that it's been shaken. The second step would be to add something that would cause it to clump up. So, I don't know if that's going to be a good shot, but this is called